Hello, my learned colleagues. In this lesson, we are going to learn about the area and perimeter of a circle. But before we go into details of area and perimeter of a circle, let's look at some important parts of a circle. And the first part we'll be looking at here is what we call chord. A chord is a straight line that runs from one side of the circumference of a circle to another side of it. You can have it here, this straight line here. Let me highlight it. This straight line here that run from one part of a circumference to another part is what we call chord. Does it mean diameter is also a chord? Yes, of course it's a chord, but it's a special type of chord. It's a special type because it divides the circle into two equal halves, and we give it a special name called diameter. And note that diameter, when you divide it into two, each half is what we call radius. So a radius is a line from the center of the circle to the circumference. This is a radius here. From here to here is also a radius, and from here to here is also a radius. So radius, therefore, is diameter divided by 2. Or in other words, two radius make up, or two radii rather, makes up a diameter. So area of a circle, what is area in the first place? Area is the amount of space that a given shape occupies. So a circle in this case, the area is the amount of space that it occupies. And how can we get that amount of space? There is a special formula used in calculating the area of a circle. And that formula is what we are going to look at in this lesson. The formula says that area of a circle is equal to pi r squared, where pi is a mathematical constant which we can get by dividing the circumference or the perimeter of a circle by the length of the diameter. What do I mean? Let me draw two different circles. This is a circle, a small one, and this is also a circle, a big one. Now, if we measure the length of the circumference, as in the distance around the circle, if we measure it, and we also measure the diameter, if we divide the length of the circumference by the length of the diameter, we obtain a special constant which is approximately 3.142. The same thing, this bigger circle, if we measure it and divide the length of the circumference or the perimeter by the length of the diameter, we obtain that same number again, 3.142. So no matter how big or how small a circle is, if you can measure the circumference and divide it by the length of the diameter, you are going to obtain this constant. And this constant is what we call pi. So area of a circle is that constant multiplied by the square of the radius. While perimeter, on the other hand, which we also call circumference of a circle, is the distance round the circle. The distance round the circle, if you can use a rope, a piece of rope, for example, to measure the distance round the circle, that distance is what we call perimeter of the circle. And for a circle, we give that perimeter a special name called circumference. The circumference of a circle is also known as the perimeter of the circle. And the formula is perimeter or circumference of a circle is 2 pi r. That is 2 times a constant pi times the radius will give you the circumference of a circle. Let's use that knowledge to solve some problem. Problem number 1 says, find the area and perimeter of the following circle. Let me label the circle A, B, and C. Let's call this circle A, Let's call this one B, and let's call this one C. Okay, starting with the area. The area, let's call it A, is equal to pi r squared. Pi is a constant whose value is approximately 3.142. The radius of this circle is not given, but the diameter is given. And we know that radius rather, is diameter divided by 2. So 6 divided by 2 there, that is 3 meters. Therefore, the area of this circle will be 3.142 times 3 square, which is 3 square is 3 times 3, right? That will have a 3.142 times 9. Let me use a calculator to do that. That gives us 28.3 approximately meter square. The unit of area is always square. So we have radius in meter here. The unit will be meter square. Okay, that is that for the area. The question says the area and the perimeter. So let's look at the perimeter. Perimeter, which we also call circumference. Perimeter rather, right? Perimeter. There is 2 pi r and 2 times 3.142 times the radius, which is 3, right there. 3. That's 6. That is 2 times 3 is 6. 6 times 3.142. I will need a calculator for that. 3.142 times 6 is 18.9 approximately meter, not centimeter, meter. Okay, that is that for A. And for B, the radius of B is 8 centimeters. So area A, which is by r square, will be 3.142 times 8 square. 8 square is 8 times 8, which is 64. So I'll have 3.142 times 64. 64 times 3.142 gives us 201.1 approximately centimeter square. Then for the perimeter is circumference. Let me just use C to denote that. 2 pi r, that is 2 times pi is 3.142 approximately, times the radius, which is 8 centimeter right there. So 2 times 8 is 16. 16 times 3.142 gives us 50.3 approximately in centimeter. And that is that for B. Now let's look at C. For C, again, diameter is given instead of radius. So radius will be diameter divided by 2, which is 18 divided by 2, which gives us 9 centimeter. So area, which is by r square, will be 3.142 times 9 square, which is 3.142 times 81. 81 times 3.142 gives us 254.5 approximately centimeter square. The circumference or the perimeter C is 2 pi r. That is 2 times 3.142 times the radius is 9 centimeter. 2 times 9 is 18. 18 times 3.142 is 56.6 approximately centimeter. Now, with this example, you can see that we can define perimeter as pi times diameter, because look at it, 2 radius give us diameter. So circumference can also be defined as pi times diameter. So instead of using this, when the diameter is given and you are calculating the perimeter or the circumference of a circle, instead of using this, you can just say circumference or perimeter is equal to pi times diameter. Putting the value right away, you will get the same thing. So that is that for example 1. Now let's move on to another aspect of circle, which is length of arc of a circle. By the way, what is an arc of a circle? An arc is formed when two radii meet at a point at the center. In this case, this length here, let me highlight it for better understanding. This length from this point down to this point is what we call the arc of a circle, and it is formed when two radii meet at the center of a circle such that an angle theta is formed. So how can we get the length of this arc? This arc, of course, is a fraction of the whole circle. So we are going to calculate the length in relation to the length or the circumference of the whole circle. So this angular distance here, which is theta, divided by the total angle in a circle, which is 360, times the circumference of a circle, 2 pi r, will give you the length of this arc. So it's a fraction of the whole circle. That is why we're dividing by 360 degrees. So length of arc, let me call it L, is theta over 360 times 2 pi r. So let's use that formula to solve some problems. We have example 2 here. So find the length of the arc in the following diagram. And as a disclaimer, I got these diagrams from an important website. Let me check. mathsworksheetforkids.com is the name of the website. mathsworksheetforkids.com. So I got all my diagrams from there. It's a good website that you can check for worksheets you want to practice on your own. So finding the length of each of these arcs, let me label this A, B, and C again. This is A, and this is B, this is C. So for A, length of arc is theta over 360 times 2 pi r. And what is theta here? Theta is 245. So 245 divided by 360 times 2 times 3.142 times the radius. Radius is 10 there. 10. Now, if I plug this number into calculator, let me do that right away. 245 times 2 times 3.142 times 10, then divided by 360 degrees, it gives me 42.8 approximately in centimeter, in meter, not centimeter. The unit of the radius there is meter. The unit of our calculation too should be in meter. So let me correct that. 0.8 meter is the length of the arc. That is that for A. Now let me do B here. B says, again, length of arc is theta over 360 times 2 pi r. Here, theta is 176. I have 176 divided by 360 times 2 times 3.142 times the radius. The radius is 4 centimeter. times 4. Again, if I plug that in my calculator, I have 176 multiplied by 2 multiplied by 3.142 and multiplied by 4, then divided by 360 degrees. It gives me 12.3 approximately. I have 12.3. What was the unit? Unit is centimeter. As the length of that arc. And then the last one, question C, the length of arc, theta over 360 times 2 pi r. What is theta there? Theta is 50 degree. I have 50 divided by 360 times 2 times 3.142 times the radius, which is 6. That gives us, again, I plug that into my calculator. 50 multiplied by 2 is of course 100 times 3.142 times 6 divided by 360 degrees. That gives me 5.2 approximately. 5.2 centimeter is the length of that arc. Okay, that is that for length of arc. Let's move on to other aspects of circle, which is area and perimeter of sector. To start with, what is a sector? A sector is formed when two radii meet at the center of a circle, center O in this case, and then this shaded portion in white is what we call the sector of a circle. It's like dividing a circle into several segments, and then one of it is shaded. That shaded part is what we call the sector of a circle. And this sector, of course, subtend an angle theta at the center of the circle. So how can we get the area of this sector? Remember, area is the amount of space enclosed by this shaded part of the circle. So that amount of space, of course, is in relation to the whole circle. That is a fraction of the whole circle, a fraction of the area of the circle. Give us this sector. That is theta, the angular amount, divided by 360, which is the total angle in the circle, multiplied by the area of the circle, which is pi r squared. So a fraction of the area of the whole circle is what we call the area of this sector. That is why we're multiplying by what? Pi r squared, which is area of the whole circle. So area of sector is equal to this. While perimeter, on the other hand, is the distance round the sector. That is, this length of line here plus this length of line here plus this length of line here, which is the arc. So perimeter, therefore, will be r, this radius here, plus this radius here, plus the length of this arc here. Let me call it L. And from our previous example, length of arc is theta over 360 times 2 pi r. Therefore, this perimeter will be r plus r is 2r plus L, which is theta over 360 times 2 pi r. So this formula here gives us the perimeter of the sector of a circle. With this knowledge, let's solve some problems. This example 3 is calculate the area and perimeter of the sector in each of the following circles. Let me label them A, B, and C. Let's call this first one A, call this one B, and we'll call this one C. So for area, let me use this color to do that area is theta over 360 times pi r squared. The angle here is 210 over 360 times pi is a constant 3.142, and the radius there is 12 inches times 12 square. That would be 210 over 360 times 3.142. 12 square is 12 times 12, which is 144. Let's plug in that into our calculator. 210 times 3.142 times 144, then divided by 360 degree. 360, it was 263.9 approximately. 0.9, what is the unit? Inches square. Inches square as the area of this sector. And for the perimeter, I will use color white. Perimeter P is 2r plus theta over 360 times 2 pi r. 2 pi r. And what is r? The r is 12, so I have 2 times 12 plus angle is 210 divided by 360 times 2 times 3.142 times the radius is 12. If we plug that into our calculator, 2 times 12 is 24. 24 rather, plus, let me plug this into calculator, 210, excuse me, 210 times 2 times 3.142 times 12 divided by 360, give me 43.98 approximately, then plus 24, that gives us 67.98 or 99 approximately inches. Excuse me. Okay, that is that for question A. Let's move on to question B. Question B. Excuse me. My tablet is misbehaving. Okay, let's come up. Now question B. Again, let me use red color for the area of the sector. Area is theta over 360 times pi r squared. And theta here is 90 degrees. I have 90 over 360 times pi. What is pi? 3.142 is a constant. And then the radius is 6 yard, 6 square. That gives us, excuse me, 90 over 360 times 3.142 times 36. That's 6 times 6. Let's plug that into calculator. 90 times 3.142 times 36 and divided by 360. That is 28.3 approximately. What is a unit? The unit is yard. So yard square is the area. Now for perimeter of a sector P is equal to 2r plus theta over 360 times 2 pi r. Okay. Now what is radius? Radius is 6. So that will be 2 times 6 plus theta is 90 degree divided by 360 times 2 times pi, which is 3.142 times 6, the radius. And that gives us 2 times 6 is 12. 12 plus, let's plug this into calculator and see what we have. 90 times 2 times 3.142 times 6 and divided by 360. That gives us 9.4 approximately, then plus 12, 21.4 yard is the perimeter of that sector. For the last one, let's do it here. What is the radius there? Radius is 19 feet. Let's use it for the area. Area, that's question C here now. Area is theta over 360 times pi r square. Theta there is 240. 240 divide 360 times pi 3.142. Then the radius is 19 times 19 square, which is, let me put that into calculator. 19 square is 19 times 19. 19 square is 361. Now 240 divide 360 times 3.142 times 361. That is 19 times 19. Then multiply by 3.142 and multiply by 240 divided by 360. 756. 756.2 approximately. What was a unit? A unit is feet. Okay, feet square. Feet square. The area of this circle, the sector rather of the circle. Now for the perimeter, perimeter P is 2r plus theta over 360 times 2 pi r, which will give us 2 times, what was the radius? The radius is 19 plus theta, which is 240 divided by 360 times 2 times pi is 3.142 and the radius is 19. And that will give us 2 times 19 is 38 plus, putting all this into calculator, that is 240 times 2 times 3.142 times 19 divided by 360. 79.6 approximately 79.6, and we add up that to 38. That is 117.6 approximately feet. That is the perimeter of the sector. That brings us to the end of area of sector and perimeter of sector. Okay, we still have one more example here. Let me shift this a little. I have more space to work. The question says, calculate the area of the sector and length of arc. Okay, in each of the following: area and length of arc. Let's start with area. Again, let me label that A, B, and C. Let's call this A. Let's call this B and let's call this C. The area of sector for A area is theta over 360 times pi r squared. And theta there is 130 divided by 360 times pi r squared. What is r? R is 11 inches. I have 3.142 multiplied by 11 squared, which is 130 divide 360 multiplied by 3.142. 11 squared is 11 times 11, which is 121. Let's plug that into calculator. 130 multiplied by 3.142 multiplied by 121 and divided by 360. It was 137.3, approximately 137.3 inches square is the area of the sector. The second question says length of the arc. Length of arc, as we know, let me do it there. Length is theta over 360 times 2 pi r, and theta is 130 divided by 360 times 2 times 3.142. R is 11. Plug in those numbers into the calculator. I have 130 multiplied by 2, that's 260, then multiplied by 3.142, multiplied by 11, divided by 360, that's 24.96. The unit is inches. Okay, that is that for question A. Now for B, let me do B here, create some space. B, area of a sector is theta over 360 times pi r squared. And that will be, what is the angle there? The angle is 190. 190 divided by 360 times 3.142 times the radius. What is the radius? 19 feet. 19 square. 19 square is 19 times 19, which is 361. So I have 190 divided by 360 times 3.142 times 361. 361 times 3.142 and times 190 degrees, all divided by 360, that is 598.6 equal to 598.6. What was the unit? The unit is feet. So feet square. That is the area of the sector of the circle. The perimeter is the perimeter or length of arc, rather. Length of arc, yes. The length of arc L is theta over 360 times 2 pi r. Theta is 190 divided by 360 times 2 times 3.142 times the radius, which is 19. Let's work on that with a calculator. 190 times 2 times 3.142 times 19 divided by 360, that is 63 63.0, 63 approximately What was the unit? Feet. This is 3 feet. Is the length of the arc of that circle. And lastly, question C. The radius there is 6 yards. The angle is 50. Question C. Let's do it here. Area of sector is theta over 360 times pi r squared. Theta is 50 degree divided by 360 times pi is 3.142 times the radius. The radius is 5, or what is it? Okay, 6 yard. 6 yard, that is 6 square, which is 50 over 360 times 3.142 times 6 times 6 is 36. Let's plug that into calculator. 50 times 3.142 times 36, then divided by 360, that's 15.7 approximately. And what was the unit? The unit is yard. So yard square. That is the area of the sector. Let's look at the perimeter now. Perimeter P. The perimeter or length of arc? Sorry, length of arc, not perimeter. Length of arc. Length of arc L is equal to 360, theta over 360 rather, times 2 pi r. Theta is 50 divided 360 times 2 times 3.142 times the radius. Radius is there 6 times 6. Putting that into calculator, we have 50 times 200 times 3.142 times 6 and divided by 360. That is 5.2 approximately yard. Okay, that is the length of that arc. And that brings us to the end of this very lesson. I hope you found it very useful. If you do, don't forget to hit the subscribe button and also like the video and share it with your learned colleagues. I'm going to do a lot of work, a lot of past question on this using IGCSE. So subscribe so that you get notified whenever I publish new content on this. Thank you for your time.